Hello everybody, my name is Gabe, and in this episode of Let's Make Rust, we're going to be completing our advanced AI. I'm sorry I haven't been uploading in a little bit, by the way. I did get pretty sick, to the point where I just couldn't record. I couldn't even speak, so there wouldn't really be a point. So, yeah, on that note, let's get started. So, we're going to go to our enemy advanced. We're going to get started by making a empty game object in our advanced AI and giving him a sphere collider. So I'm going to make that a little bigger, because what's going to happen is if we get into if we're in this range and we hit the enemy, we want to be able to also be what's it called? We want to be chaseable, sorry, if we hit the enemy, because if we hit the enemy, it would only make sense if for him to realize, oh, there's someone hitting me, let's go chase after him. Make sure his trigger is enabled as well. And in script, I'm going to make a separate script here, and I'll just call this player detector. Alright, so once you've opened up the script, you can now make a private transform, and we'll actually call this player transform. And we're going to make a private void on trigger enter. And in here, we're going to do collider target. And if target dot tag is equal to player, so if the object's tag is player, we're gonna set that player transform. Player transform is equal to target dot get component transform. Alright, so back in our advanced enemy AI script, right over here where player transform equals hit info dot collider dot get component. I'm actually going to make another if statement. We're going to do if player transform is equal to null. So if it's empty, we'll just do that. So if player transform is empty, then we will find it off of the raycast. Otherwise, in the player detector, we will get this player transform. Hold on, I'll just change this to player detector transform, and then we're going to get a script. So we're going to do private advanced enemy AI, and I'll just call this enemy, or I'll just call this advanced enemy AI. And in a private void start, I'm going to do advanced enemy AI is equal to get component in parent advanced enemy AI. So we're going to find the advanced enemy AI script. Okay, so now the if advanced enemy AI dot we're gonna have to actually go back here and make this public. So over here in the player transform, we're gonna have to make this public because we're gonna access this from the player detector script. So if the advanced enemy AI player transform is equal to null, then we will now set player transform, or sorry, advanced enemy AI that player transform to our player detector transform. Alright, so that was probably really fast and maybe confusing. I could explain to you what's happening though. So in our player detector here, once this compiles, I'll just call this player detector and apply, and I'll apply that player detector script. Okay, so what's happening is if our player comes into this sphere collider, he will be found by the enemy. The enemy will know what transform is the player. We could just save a lot of time and make it find him in the beginning, but the thing is that if we are going to make this multiplayer in the future, we're going to have to just keep it like this. We're rather future-proofing it. So over here, if it has not already been found by the raycast, it'll now be found by the sphere collider, and vice versa. Okay, so let's test that out and see if it works. Should get no errors. Okay, so I have the player transform open here so that we could see it, and once we enter the trigger, we should be able to, something should pop up here. So let's go in, and now, there you go, we have the player transform recognized by the enemy. And if we leave, it should still be recognized, excuse me. Also, if you are not seeing this in the game view, the reason is because you probably don't have gizmos checked up here. These are all the gizmos I have enabled. I think I have all of them enabled, yeah. Okay, so if you enable gizmos, you'll be able to see what you would see in the editor as well. Or sorry, in the scene view. Okay, so that works. We'll now do if we attack the enemy. So let's get started on that. Okay, so on take damage, we'll do over here if player transform is not equal to null, then is chasing is equal to true. So if we do have the player transform is true, another reason we're doing this is because if we're going to be shooting the enemy from afar, we're not going to get any errors now, like this. So if I go up to the enemy now and left click on him, if I attack him, he should start chasing me. Sorry, gotta get my... Yeah, there he goes. Alright, so that's working perfect. So if we restart the game, should work exactly the same. So if I come from behind, over here, and left click, there he goes. He's chasing me now. Alright, so that's going well. Right now, I'm actually going to make the ray, this ray, I'm going to actually make it eye level, so we can, in the future, when we have a model for the enemy, it'll work out, because we're going to have that set to a variable, his eye height, so it'll be what we want it to be in the editor. We could just change that very easily. So if we go back to the advanced enemy AI and go to the raycast, we're actually going to have to make a new vector. So I'm going to make up here a vector 3 called eye position, which is equal to a new vector 3, and transform.position.x is fine. Now this is different. We'll do transform.position .y plus eye height. So we'll make a public int here, or we'll make it a float, eye height, and by default just nothing. And we will do transform.position.z, .z, and close that off. And instead of setting to transform.position, we're going to do eye position. Okay, so now if we hit play and we go into the editor here, and if we adjust the eye height, you can see now we can change the height of the ray accordingly with the variable. Now, I'm not sure why this is happening, why we were getting two rays being drawn. I'll see what the problem is in just a sec. Okay, so I figured out what the problem is, and it's pretty retarded. I actually have applied the script twice for some reason. I don't really know why. So now that we have it applied once, it should work normally. We should be able to see just one ray. So if I adjust the eye height, we should see now, yes, there's only one ray being drawn now. So now we could pick a good number for our eye height. So I'd say right about here, which is 0.75. So we'll stop the game, change it to 0.75, apply, and once we hit play again, it'll be at 0.75. And there we go. So that works totally fine. So now if we go up to the enemy, oops, didn't mean to do that. If we go up to the enemy and hit him, that might have caused some problems just by me bumping him. So if we go up to the enemy and attack him, it'll work just as it did before. And if we go up to the enemy through the ray, he will detect us through the eye height as well. So yeah, okay. Alright, so now we're going to be doing something a little bit more advanced. We're going to be doing wandering to finish off this episode, because it is going pretty long. So I'm gonna make a public float here called think timer. And this is how long it's going to take for the AI to think again. Right now we'll just have it set for a number, and then one day we'll make it random, so they are really all just random, but right now we'll just make them all think at the same time. So we'll make him equal to let's say 10 or 5 seconds. That'll be fine. So I'm gonna make a let's see, an update. We're gonna do think timer minus or equals time dot delta time, and if think timer is less than or equal to 0, then we're gonna call think, which we're gonna make a method called think. Okay, we have to probably make that first, so I'll just make that right now. Private void think. Okay, and think timer is going to equal to think timer start. And think timer start, so I'll make a private void here, or sorry, apply private float, think timer start. And in start, we'll do think timer start is equal to think timer. Okay, so now we have an ongoing timer, and every time it hits 0, it'll or less than 0, it'll reset and call this function. And in this function, we are going to pick a random location for the enemy to wander around. So we'll do if not is chasing, or sorry, I prefer actually to do if is chasing is equal to false, but you can also do if not is chasing, like this. Up to you. Okay, so if is chasing is false, then we're going to make a vector 3 called new position, which is equal to transform.position plus a new vector 3, which is random dot inside unit circle dot x, and we're gonna do transform.position dot y and random dot inside unit circle dot z, or sorry, dot y for the z. And we're actually going to multiply this by radius. So up here, I'll make another variable. So we'll do public, let's see, what should we call this? It'll be a float, random area position, random unit circle radius is equal to, let's say 10. Okay, so back down here, I'm going to multiply this by our random unit circle radius, and I'm also going to multiply this by our random unit circle radius. Okay, now what's happening here is we're actually using a vector 2 function, but we're applying that to a vector 3 function because, well, what's happening is it's in a circle for the x and y, but we want to keep our y the same, so we'll just keep it the way it was already, and for the x we can keep the same, but the y for the circle for the vector 2 will just be the vector 3z. Not sure if that made sense, but I hope it did. Okay, I actually forgot to do something very important. I forgot to do agent.setDestination to new pos. That's very important. Okay, so let's try that again. So if we hit play, we could see the timer is going down, and once it hits 0, we should see the enemy is now moving to wherever he kind of feels like. So let's watch again. There he goes. He's just kind of moving however he feels, and yeah, that's kind of working. So we can just, I guess we could do it right now. We'll make some of the variables more random. Like the think timer, maybe he doesn't have to think every 5 seconds. Maybe he'll think between 5 seconds and 15 seconds. So I think we'll just do that instead. So up here for our think timer, I'm gonna make a private float think timer min and private float think timer max. And I guess we could set this now 5 and 15. We can remove this, and think timer is equal to random.range between think timer minimum and think timer max. And yeah, there we go. So that'll be now a random number between these two. We had a problem. Okay, I'm not sure what the problem was, but I just retyped it. Okay, so we randomized the think timer. We could also randomize the unit circle, unity circle. Oops, I'll rename that. Random unit circle radius. Okay. We don't have to randomize this, I guess. This is fine. We can do a set radius. We'll do something bigger though. I'll do 25. Gives us a lot more room. Okay, so let's try that again. When we start, we should see it's at 5, but let's actually change that. At start, we'll randomize it as well. So we'll do think timer is equal to random.range, and from think timer minimum to think timer max. I could have copied and pasted it, but I was already doing it. Okay, and I guess we could remove this. It doesn't really matter. Or, no, we'll keep it. Whatever. Doesn't really matter what we set this to. It's going to be reset. So if we hit play now, we should see our think timer. It was about 6 seconds, 7 seconds. And once it starts again, we're at 7 seconds. So it's randomized now a little bit more. So try again, and as you can see, it was around 13 seconds. So yeah, we did a little bit of randomness, and yeah, so thanks for watching, guys. I hope you liked the video, and let me know what you thought. Have a good one.